Hello everyone and welcome to Coding Cart. So in this tutorial we are going to solve one LeetCode problem from the topic linked list. So you can see here the problem name is swap nodes in pairs. So in this problem we will be given one linked list, and what we have to do here is we have to swap every two adjacent nodes, and at the end we have to return the head pointer. So let me explain you here with this example. Suppose here we are given one linked list having value 1, 2, 3 and 4. So what we have to do here is we have to swap every two adjacent node. So here these are the two adjacent node, and here these two are the adjacent node. So we have to swap these two nodes. So after swapping, this will be the output, and for this one it will be 4 and 3, and this will be connected to 4. So this will be my resultant linked list, and we have to return this head, which is 2. So you can see here the output 2143 after swapping 2143. So this is the problem here. Means here they will give one linked list, and what we have to do here is we have to swap every two adjacent node, and at the end we have to return the head pointer. So how to solve this one? Let us go part wise. Suppose we have a linked list having value 1 and there is only one node. So what to do? We cannot swap this one. We will simply return this, and this will be our head pointer. We will simply return this one. We will simply return this one. Return head if we have single node linked list. Now we have to think our logic if the number of node is greater than 1. So for example, a linked list is having value 1 and 2. Suppose there are two nodes. Let us take another example. 1, 2. There are three nodes and one example. Suppose there are four nodes. 1, 2, 3 and 4. So here we will cover both the situation. Odd number of nodes and even number of nodes. So suppose there are only two nodes. So what we will do? We will simply apply a logic like, suppose this is pointer P1, this is P2. So if you write here P2 dot next, P2 dot next, which is currently none, equal to P1. So it will point to P1, and if I write in next line P1 dot next equal to P2 dot next, so it will look like P1 dot next is pointing to P2 dot next, which is none. So after this one it will look like 2 is pointing to 1 and 1 is pointing to none. So here you can see here it got swapped in these two lines, correct, for two nodes. What about if you have more than two nodes? Suppose if you are writing here P1, P2, and suppose this is P3. So at a time here we are working with two adjacent nodes. So we have taken here P3 just to hold the remaining address of the linked list. Now suppose if I write a logic for this one for three nodes like 1, 2 and 3. These are my nodes. Now if I write a logic like P1, this is my P1, P2 and P3. P3 is holding the rest node address, and here we are simply first playing with P1 and P2. If I write here P2 dot next, P2 dot next equal to P1, so it will look like 1, 2, 3. 3 is pointed by P3. Here we have written P2 dot next equal to P1. P2 dot next equal to P1. Okay. Now in next line, if I write here P1 dot next, you point to P3. So it will look like P1 dot next is pointing to P3. Now if I draw the picture, it will look like 2 is pointing to 1 and 1 is pointing to 3. Correct? See this one. 2 is pointing to 1, 1 is pointing to 3. So we are done with the first two adjacent nodes. Now this is P3. Now we don't have any adjacent nodes, so swapping is not possible here. So for three number of nodes, we can simply write a logic to escape, like whenever this p3 dot next is none, we can simply stop. Okay, I will write the code and explain you again one more time. Now see what will happen if we have four nodes, means even number of nodes. So this will be my p1, p2 and p3. So at a time we are only playing with two adjacent nodes. So here we have given p3 just to hold the remaining linked list. Okay, so here if I write a logic like the same logic, if I write here p2 dot next equal to p1. Okay, so it will look like, and let me first again write, and p1 dot next equal to p3. So it will look like 1, we have 1, 2, 3 and 4. 3 is connected to 4. This is my p3, and we have written here p2 dot next. This was my p1, this was p2. We have written here p2 dot next equal to p1, p2 dot next equal to p1, and p1 dot next equal to p3, p1 dot next equal to p3. So it will look like 2 is connected with 1, 1 is connected with, 1 is showing to 3, and 3 is connected to 4. Okay, and my pointer was, this was p1, 2 was p2, and this was p3. So we are done with these two adjacent node. We have already swapped this one. Now we have to play with these two. So what we will do here, we will move forward. We will move our pointer to the next. Like if I write here p2, you go to the address of p3. p2 equal to p3. So this will be my p2. And if I write here p3, you go to the address like p3 dot next. So let me erase this one. So p3 will be denoting p3 dot next. So this will be my p3. This will be none. Now if I write a logic like, suppose after swapping it will look like 2 is connected to 1 and 1 is connected with this, 3 and 4 will be swapped. So 4 will come here and 3 will go here. So 1 is connected to 4 means, 1 is connected to 4 means p1 dot next equal to, p1 dot next is showing to this one 4, and 4 will be denoted by p2 dot next, correct? So it will look like p1 is showing to p2 dot next. It means 1 is connected with 4. Now in the next line, if I write here p2 dot next, p2 dot next, this pointer you point to p2 equal to p2. So it will look like 2 is connected to 1, 1 is connected to 4, and 4 is connected to 3. Okay, it will look like 2 is connected to 1, 1 is connected to 4, and 4 is connected to 3, and 3 dot next is also showing here. Okay, this pointer. So what we will do, 3 is my p2. What we will do here, we will simply write p2 dot next equal to p3. p2 dot next equal to p3, you show to the p3. So p2 dot next, instead of showing here, you show to p3, and p3 is currently none, so it will be none. You can see here. So we are done. You can see here the value got swapped. Now here p3 is none. So how to stop this one? When we have even number of nodes, we will check whenever p3 is none, then we will simply stop. And for the odd number, we have checked, like for the odd number here, we cannot swipe the odd number. Here we were checking p3 dot next is none, then we will simply stop for the odd number. So let me write the logic here, then I will again explain one more time so that it will be more clear. So let us write the logic here. What is our first target? first target is to check if we have single node, means our first target is to check the boundary condition. Here our very first boundary condition is we will check if head is none. Means here we are simply checking if the linked list provided is empty, then we'll simply return. Or at the same time they are passing a single node linked list. So for that we will check or head dot next is none. So what we will do, we'll simply return head. So this is my boundary condition check. Now we will apply our logic for more than single nodes linked list. So what we will do, for better understanding, we will take 3-pointer. Let us take p1 equal to head, p2 equal to p1 dot next, and let us take one p3 equal to p2 dot next. Now if you see here, suppose this is my linked list having value 1 and 2, suppose one more node 3. So whenever these two adjacent nodes are swapped, our head is always p2. Suppose this is p1, this is p2, and this is p3. So whenever this two adjacent node is swapped, after swapping we will get 2 1 3. So our head is the node p2, so we will assign first the head. So head will be p2. Now we will apply our logic. Now here we have assigned 3-pointer p1 p2 and p3. Now we will apply the logic of swapping here. Suppose this is 1, this is 2. Suppose there are only 2 nodes, so this will be my p1 equal to head, p2 equal to p1 dot next, and p3 equal to p2 dot next. This is p3, which is none currently. Now we have to swap this p1 and p2. So what we will write, code p2 dot next equal to p1 and p1 dot next equal to p3. Correct? So it will look like 2 is connected to 1 and 1 is connected to none. So we will write the same logic here. p2 dot next equal to p1 and p1 dot next you point to direct p3. We are done for the 2 nodes. Now we will use a while loop to check whether we have to perform this operation for the multiple nodes present in the linked list. So you can see here the remaining nodes were taken care by which pointer. Suppose we have 1 2 3 4 5 6, suppose 7. So we were playing with p1 and p2 at a time, and the remaining were taken care by p3 pointer. So let us use while loop while, and we will check the condition for both even and odd number of nodes. So for even number of nodes, when we have to break the loop, when p3 is none, you can see here when p3 was none, after doing all the operation we will break. And for odd, the condition was this one, p3 dot next is none, means only one single node is present in the odd part after doing the swapping of adjacent node. So here we'll write while p3 not none, and at the same time we will check p3 dot next is not none. Then only we are going for the next operation. Now let me explain you here again. Suppose there are linked list. Suppose we have linked list having value 1 2 3 and 4. So this was p1 p2 and p3. So we have already written the logic for swapping p1 and p2 here, this 3 lines of code. Now after swapping, the values are 2 1 3 4. p3 is holding the remaining linked list. 1 was pointed by p1 and the node 2 was pointed by p2. Now we are in while condition. So what we have to do here? So these two nodes are swapped. Now after that we have to perform operation for the next at two adjacent nodes. So here P2 will move to the position of P3 and P3 will move to the position P2 dot next means next dot next here. So P3 will be showing to none. This is none. Now we will do the operation for these two. So for that we have to first move P2 equal to, it will go to the position of P3 and P3 will move to the position P3 dot next. Okay. Now we are done. We have 2, 1, 3, 4. This is my P2 and this is my P3 showing none. Now what we have to do here is, this is my P1. So after swapping, suppose these values are swapped, it will look like 2 is connected to 1, 1 is connected to 4. Once these two nodes are swapped, 4 will come first and then 3. So 1 is connected to 4. So what we will write here, P1 dot next equal to P2 dot next. So P1 dot next, you point to P2 dot next, P2 dot next. So 1 is pointing to 4 and after that 4 is pointing to 3 means 4 you point to 3. So 4 will be denoted by P2 dot next, P2 dot next and your pointer is P2 dot next, you point to P2 means P2 dot next, it will give 4 and 4 next dot next is the pointer you point to P2 and P2 is having value 3. Okay. So P2 dot next you point to P2. Now we are done. So you can see here 2 is connected to 1, 1 is connected to 4 and 4 is connected to 3 and also here 3 was connected to 4 here. Currently P2 dot next is showing to 4 means one pointer is connected like this. So what we will do here, this is 3 is denoted by P2. So what we will write? So what we will write, instead of showing here you P2 dot next, you show to P3 which is currently none. So show to P3. P3 is none. So we will write here P2 dot next you show to P3 whatever the value P3 is holding. So this is currently none for the even number of nodes. So we are done. This is our logic. Now what will happen if we have multiple nodes more than 4? Suppose 1, 2, 3, 4, 5 and 6. So we'll apply the same logic here, P1, P2 and P3. These two will be swapped like 2, 1. This is P2, this is P1 and rest is denoted by, this is 3, 4, 5, 6. This was denoted by P3. We will move this P2 to position of P3. This will be moved to the position of P3. This is also showing P. This is also P3 currently, and now P3 will move to P3 dot next. So P3 will be moved to here. Now we have to swap these two adjacent nodes, and currently P3 is holding the remaining linked list. So again we'll write the same logic here, means again this loop will be executed. So again we'll write P2 dot next means 2 is connected to 1. So whenever these two nodes are swapped, it will look like 4, 3. 1 is connected to 4, 4 is connected to 3 and 3 is connected to 5, 5 is connected to 6. So currently we are here. This is my P1. So P1 dot next should point to P2 dot next So here if you see here, 1 is connected to 4, 1 is connected to 4. So how can we write this one? If you write here p1 dot next equal to p2 dot next, p1 dot next equal to p2 dot next. So 1 will be connected to 4. So we have already written this logic, p1 dot next equal to p2 dot next. Now 4 is connected to 3 means p2 dot next you now point to p2. So we have already written this p2 dot next equal to p2. We have already written that one, p2 dot next equal to p2 means, let me remove this all, means this is my p2, this is p2 dot next means this link you point to p2. So we have written p2 dot next, p2 dot next will go to position 4, dot next means its link part, you point to p2, you point to p2. So 4 is swing to 3. Okay, now we have written p2 dot next, p2 dot next, this pointer, this one, you point to p3 equal to p3. So 3 is swing to 5. So you can see here 3 is swing to 5. This is quite complex here, you can see here, but if you go code wise it is simple. Now we are done. You can see here the value got swapped here. Now let me write the pointer name. 3 was denoted by p2 and 5 was denoted by p3. Now if you see here, these two nodes swapped, these two nodes are done. Now we have to play with 5 and 6, these two. Now let us write here one more time. 2 is connected to 1, 1 is connected to 4, 4 is connected to 3, 3 is connected to 5 and 5 is connected to 6. So swapping is done for these two nodes, these two nodes. We have here p1, 3 was denoted by p2 and 5 was denoted by p3. So once this operation are done, we will change the position of pointer p1. Now p1 you go to the position of p2. So now p1 is also showing to node 3 and p2 is also showing to node 3. Now it will go again in while condition. Now we will change here. After all this operation, we will write p1. Now you change your position. p1 equal to, you go to the position of p2. Now we are done. Now see here, we have replaced the pointer. Now let me write again here 2, 1, 4, 3, 5 and 6. This is my p1 and this is my p2 as well. This is my p3. Now if you see here in the code, now let me explain you line by line here. Let me copy this one and explain you here line by line. Let me paste here. Now you can see here p3 is not none and p3 dot next is also not none. Now we are assigning here p2 equal to p3 means p2 you go to the position of p3. p3 is currently node 5. Now this line is done. Now p3 equal to p3 dot next. So p3 go to the position p3 dot next which is none. So this will be denoted by p3. This line is done. Now p1 dot next equal to p2 dot next. p1 dot next equal to p2 dot next. So p1 dot next means after reversing it will look like 2, 1, 4, 3, 6 and 5. Okay, so p1 was currently node 3. That's why we have written p1 means 3 have to show to node 6. So p1 dot next directly show to p2 dot next. So this line is done. 3 is showing, 3 dot next is showing to node 6. In the next line 6 is connected to 5. So p2 dot next p2 dot next you show to p2. means this 6 dot next is showing to node 5. So this line is done. Now in the next line we have written p2 dot next you show to p3. You can see here 5 is currently showing to none. So 5 dot next means p2 dot next you show to p3. So 5 means p2 dot next equal to p3. So 5 dot next is showing to p3, which is currently none. And at the end we are changing p1, you go to the position of p2. P1 you go to the position of p2. So p2 and p1 are currently showing to 5. So this is p2 and this is also p1 after the conversion, and p3 is none. Now we are done here. Now it will go in loop and it will check p3 is not none, but here p3 is none. P3 is none, so it will come out. Now after that, if you see here, we have already swept all the nodes, so this logic is working fine. So at the end what we will do, we have to return, at the end we have to return head, and we have already calculated head here. Head is always the p2, means the second node, always the second node. You can see here, if my linked list is having value 1 2 3 4 5 6, then my node is always the second one. That's why when we were assigning p1 p2 and p3, we have assigned head equal to p2. So everything is okay. Let us run this code. So you can see here it is working fine. Let us submit this code. So it got accepted. So that's all for this problem here. Means basically I have explained you with the help of 3-pointer just for easy understanding. So I hope you understood this problem. So if you have learned something new, please do like our videos and subscribe to our channel Coding Cart, and stay tuned for the next videos. Thanks for watching.